Hello again. Welcome to the third video in the tutorial series linked to the computer networking course for computer science at the University of Hull, where we're giving a demonstration of programming clients and servers in C#. So far we've produced a specimen client that's talked to a whois server. We've produced this server that started work on the specification of an assignment, and everything looks like it's doing fine. Anything, it might seem that we just have to go through the other stages. We've got up to stage 2, stage 3, 4, 5, 6, 7, implement all the coursework, hand in, get a fantastic mark, and all is finished. But we're doing another video here that's not related to a particular stage to remind you some other things. So if we handed in the work that we've done so far, it's actually done in quite a novice way, and it wouldn't really be acceptable to professional standards, and very likely only achieve a bare pass, because there's much more to programming than just writing some code, be it simple or complex. So we're going to try and address some of the more important things that you need to do to make your code have added value, to be worth more, and you be rewarded more for it. So the kind of things I'm going to look at are code readability, code style, documentation, the writing of comments, how to test the code to the specifications, and how we can do it in relation to this particular assignment and in the particular lab. And there's also some things about Visual Studio and C# programming that you will learn while going through these points. And there's a last postscript that one can talk about. Is although all of this appears to be done in C# on a Microsoft Windows platform with Visual Studio, what about on Macintosh? What about Linux platforms? What can we do there? Well, I'll leave that as a rhetorical unanswered question. So let's move on. So here we are where we left the last video. We're in Visual Studio. We've got our code here. So it's pretty devoid of comments. The only time we've used a comment is to delete out some old code, and quite often you see a student submission like that. It doesn't say very much, and it doesn't help the marker mark it, and if this code went to somebody else who hadn't seen the videos, they might have trouble understanding it. So these are one of the issues that we have to address. Visual Studio has a feature to help with that, and one of the things that we can do is, for example, we can start to document these methods. And if you put 3 slashes there just before a method, you'll magically find that Visual Studio is able to create a framework of comments for this, and so we can put this. We can write something about this method and start to do our documentation. So this method is called after the server receives a connection on a listener, it processes the lines received as a request in the desired protocol and sends back appropriate replies. So we could do something like that. Then we could go to this one and we could do something similar. Okay. This method is called by the main program to create server is in a separate method to facilitate threading at a later date. Now we haven't talked about threading, but that's one of the reasons why we've done that. So we can do the same here. This is the main program for a console application that is invoked with an array of strings that were received on the command line. There's another thing there. You notice that this line has gone on very long. You should be wary of having lines that are too long, because pieces of paper aren't always as wide as your screen. So it looks nice to have very nice long lines if you've got a wide screen, but we don't have really wide paper. And so it's also a good habit to keep it usually within 72 columns actually. I made a spelling mistake there. Notice there's no spell checking in there, so you need to have another method for spell checking. So we put some comments in, but that's usually not good enough. We have to say, would the person understand what's going on? So we probably need to put some line by line comments in the code here. So we could create a TCP socket to listen on port 43 for incoming requests. And start listening. Now, one of the things that's quite often a bad idea is to put the comments line by line. So I've put a little piece of commentary here that probably represents several lines in a section of code. And we can actually use some of the folding mechanisms within Visual Studio to package those as regions. Then also that will make the code more readable. So here we can say we've done a while loop. We can say loop forever, handling all incoming requests. And a request is received. Socket to handle it, and invoke do request to handle the details. Request is complete. Close the sockets as they are no longer needed. If there was an error in the processing, catch it and note the details. So I've attempted to make that code a little more readable, and now in do request we've got some things here. Code could generate some stream readers. Now that's something interesting to say there. You might find that there are other tutorials, both on YouTube and in textbooks, that show you how to do clients and servers, and they do some quite complicated things to do with byte arrays, and in fact some of them the code doesn't work fully. And you don't need to do that, because C# gives you stream readers and stream writers that solve all the problem of handling textual lines in and textual lines out, and particularly students in the computer science course were taught how to do them last year. It's in Rob Miles' yellow book, and that should be the way you're doing it. Less likely to get bugs because the code is simpler, more straightforward. Now then, we've got our stream readers, and here we're reading the first line. Read the first line of the request and trim the /r/n or carry return line feed. That's what's happening there. And then in this part we can say divide at the first space character. Now that split that we've done could also be done otherwise. You could actually use substring to do that, but it's just more elegant with the split there. So, and then we can say switch the command part of the request. So there we are. I've written some comments now over our little server, and it goes over a screen. It's a little longer now, but it would be more acceptable for a piece of programming, and if a person came to it for the first time, they've got a better chance of understanding what it's about. The last thing to add to the program is we haven't got a comment at the top. So if we just go to the top here, and we can put a summary of the whole program. So we can put various bits of information like the name. This is a server for the client-to-end server networking assignment. We probably should tag it with an author and one of the problems is you shouldn't put your name because coursework is put in anonymously, so we could put in the student number of the author, and it's quite often good convention to put some kind of history. When it was created. So that's probably good enough, and we can save that. So let's look at some other things that we can do. Now we've got that, perhaps we could validate that this matches the standards. And one of the things that's happening are available in our networking lab in computer science is there actually are some testing scripts available. Now it does say in the assignment, let's go and look at the assignment. Right at the top it does say these applications will be components of a larger software system. Well, there's an emulation of a larger software system in some command scripts which are made available in the lab. They're not described in the document here, but I can now in this video briefly show how we could use the command scripts to get some things working. So previously we were in a command prompt and we were running the thing called class client, and this was in the step 1 video that called a whois server. And we talked briefly about some possible faults in there. Let's go and look at the kind of thing that's available. So all students will have a student share drive, that's their U drive at the University of Hull. And they can go to computer science and they can go to the section for the module. And here I've made a directory called YouTube example, which contains some scripting that can be used to invoke the code that we've just produced and test that it's working in the framework, and we can see if it's acceptable. There's a little piece of documentation called a README which we can click on and we can look at. So there's some brief instructions there, but I will close that. Now these test scripts are activated by using the setup script which we run, and the setup script makes a fake drive called T for test, which points into this directory. So I just have to hit carriage return. I don't need to do anything else, and this step 1 test and step 2 test and any others are available to me. So I can now go to this directory where we were earlier running the program from the video for step 1, and I can do T : step 1 test, and it actually will now call or invoke mechanically this class client that we called over earlier and check that it works. So it said it couldn't find the thing called connect, because actually it isn't called connect. This one is actually called class client. So we found a few errors even there. If we'd called it the wrong name, the testing script picks that up. So it's invoking the thing called class client. Behind the scenes, and it's actually run a test. Can it look up network solutions and get the right answer? And it says OK, and then it says, would you like any more sophisticated testing? I could say yes, and then it's got a disclaimer that says, well, you're responsible for your own testing, you don't have to trust these. And it's doing various things. It's calling it with no arguments, and it checks that we get the error no arguments provided, and it says that's okay. it called it with too many arguments to see what happened, and I did mention when we're looking at the code that we didn't give an error message with 2, and it calls it with an actual argument that's a null string to see what happens. So it's attempting to see how well it does, and that one seems to have worked okay. And in this particular testing script we could actually save the output to a file. By putting no colour as the last one, and then we can save the output to test results.txt. And now it will run those tests without sending any output to the screen. So it takes a few seconds to run, and then we can look at those. So I can say, no, I don't want to run the more challenging tests. And now I can look at a file called test. And you can see the output is in a file confirming that the tests were done, and that could be provided as evidence that the programming task is complete and that tests have been run. So we can go and do this same piece of testing on step 2, the server. So we just find the directory for that, which I happen to know is here. And there's the program called respond. So I could run T step 2 test, and I could run the test script. Now you see it's found the server and launched it automatically, and now it's sending commands to the server that's logging to the screen, and over here it's going, oh, it's testing the null operation, that's okay. It's testing the echo operation, that's okay. But no, look, it's got test 4 failed at server timeout. And you're thinking, server timeout? I don't remember anything about server timeout. But if we go back to our description, it does actually say here, in all cases, both the client and the server should give up and drop the connection if they're left waiting for more than 1 second. Oh no. So that's a feature in our step 2 server that we didn't implement, and that was picked up by the testing. So we need to go back and find out how to implement that, which means we need to go back to Visual Studio, and we need to work out how in our program can we get that right. Well, IntelliSense can help us here, because there are features that control timeout, how long something takes. So we can try and look. So if we want to look on this connection, we can go down and we can look at what's available here. See, there's something called receive timeout. And they will also be available on the socket streams. So we should be able to do socket stream dot can put a read read timeout. Sets the amount of time that a read operation blocks waiting for data. So we can put read timeout, and we can quickly go back to the spec, and it says 1000 milliseconds. So we can put 1000 in there. And actually if we scroll down a little more, we would actually see there is a write timeout. So just by putting those two things in, we've set the timeout value. Now don't forget to put a comment. Set the timeout value to 1 second. We can now save that. We can now build the solution. And then if we go back to our testing, we can now run our step 2 test script, and we can see if that now passes the timeout test. So it's caught that little feature that we overlooked, and that's the advantage of testing separately. So it actually says server timeout is okay, and then it says would you like to try some more tests, and we can go yes, and it actually will pass a null string at various places, an echo without anything, and that seems to pass okay. So we can now save that output in a file as proof. Now it's passed the validation test of the test script. You might ask, how could we have tested the timeout without using a script had we known about it? Now that's quite simple to do. Let's run the server. I can do that by just pressing the start button and get the command prompt back, and it started listing. We can just telnet to it as before, and we just don't type anything, and we get that message something went wrong, and we get the prompt back because it's here. It says something went wrong. That's actually the timeout. So we could do that, and then in 1 second later it says something went wrong and disconnects, which is exactly what the timeout does. So you can see we didn't actually need the test script if we knew what to do. Welcome back. Now the next part of professionalising our approach to solving this networking assignment is to use some source control, and in particular subversion, or SVN, which is a tool used in computer science here. So on the intranet site for the Department of Computer Science, and if we look at the systems software library, we have some information about getting started on subversion. So the first thing to do is read those documents that are provided by the systems team, and the first one is a Word version, a Word document that explains to us we need to get hold of a copy of Visual SVN. So Visual SVN is here. So we need to copy that link and go and get a copy of this SVN. So now we can open and install. We can install all the pieces. Right, so now we've downloaded the Tortoise SVN from here. We also, further down the instructions, it says we need to download and install Visual SVN and then register it. So we need to go to our web browser again. And we can click on the download button and download now a copy of Visual SVN. Which we can then install. In the normal way. And I've actually installed it earlier, but I can quickly install it again. Okay, now we've downloaded and installed both the Tortoise SVN and the Visual SVN. If we look up here on Visual Studio, we haven't got any menus, so we need to save everything and then exit the Visual Studio and then restart the Visual Studio, and we should get the menus up now. So if we restart the Visual Studio, it should now load the Visual SVN component, and then we can start the registration and start using SVN on our project solution. Very good, and you see now here we've got the Visual SVN menu, and we need to do the quick registration. We can enter now we've got the University of Hull license, we can close. So now we can open the previous project, and if we go down here to recent projects and solutions, we were looking at Respond. So here we've got the solution that we had before. Now we've installed Visual SVN and registered it, we can add this solution to SVN, so it's the one in G08241 Respond, and we want to add it to existing repository, and we want to add it to the Department of Computer Science repository, which is https://visual.svn.hull.ac.uk/svn, and then your user ID. Right, and now it's adding it. Successfully added to Subversion. And just before we finish with SVN, you'll notice there are some coloured dots against the files here. That's because the solution hasn't been committed to SVN, and that means it's still locally on the machine. So we need to actually commit all of these changes up to the Department of Computer Science server. That sent them up to the server, and if we wanted to, we could go to the repository, and you will see that the project is now on the departmental server. So now we've put it on SVN, we can go back to step 3 of working on the coursework. Now we've professionalised it. These buttons have changed to green, by the way. So next time we want to make some changes, we need to tell SVN we need to do some updates. Hope you found that useful and look forward to the next video. Complete program, and it's more professional with the comments in. We've learned a bit more about network sockets, about the timeout. We've learned more about Visual Studio, the way it can write comments, and we've learned more about being professional, testing it, and generally how to improve things, and we'll follow up on that stone as we continue through the exercise and the tutorials. Now, as a brief postscript, I said, what about the question, do I have to do this on Visual Studio? No. You can program in C#, and there is a C# system called Mono, and Mono runs on Macintosh and Linux, and Mono also runs on Windows platforms, so you don't have to have Visual Studio. And I've also done this code using Mono. So to explore that in too much detail is outside the scope of this video, but we could show how we can run these managed code programs in C#, for example, on OS 10 on a Mac, and there are web pages on how to do that. Right, so that completes our task for this video, and we will go back and start looking at stage 3 in the next video. Thanks very much.